I get this question quite often. As a DevOps engineer, do I need to learn how to code? And what is the best programming language and where do I start? Now, as a DevOps engineer, you do not necessarily need to know how to code, but understanding the different strengths and weaknesses of a programming language and the basic fundamentals of programming will make you a far better engineer than someone who doesn't. It'll help you understand some of the developer mindset and workflow, and also understand some CI/CD components like integration and unit testing. It'll also enhance your troubleshooting skills because you'll understand how the application works. All of these things will help you improve developer agility, and understanding the basics on how to code will help you write your own tools, which can help you extend your platform beyond its capabilities and take your DevOps engineering to the next level. In this video, we're going to be taking a look at an introduction to Python. We have a lot to cover in this video, so without further ado, let's go. So if you take a look at the GitHub repo, we have a Python folder, and in the Python folder we have an introduction folder with a README. And here is all the instructions we're going to be looking at today for the introduction to learning Python. We're going to start with the documentation, downloading Python, take a look at how to run Python in a Docker container. Our first program, we're going to take a look at the source code and break it down and look at all the fundamentals of learning Python programming language. So be sure to check out the link down below to the source code so you can follow along. So the first thing we're going to be looking at is the documentation at www.python.org. Now the Python website is pretty awesome. There's a download section where you can take a look at the source code as well as the download links for all the different platforms. They have documentations with tutorials, beginner's guides, and you can go directly into the Python documentation for each version of Python. Now one thing to know about Python is that there's two major versions of Python, Python 2 and Python 3. Now in terms of differences, Python 3 is somewhat backwards compatible with Python 2. So I would recommend to simply focus on the latest version of Python, which you can download over here, which is Python 3.9. And this brings me to my next point, which as a DevOps engineer, you're probably going to want to focus on running Python inside of Docker. Running Python inside of a container helps maintain portability, which means you can run Python 2 as well as Python 3 without installing any version of Python on your local machine. So it helps resolve version conflict and makes your application portable so that other engineers can run it with ease. So if we head over to Docker Hub, we can find all the official container images over here. If we take a look at tags, we can find different flavors of Alpine, and all these container images have different OS distributions as well, so you can pick any one you like. So in this video, what I'm going to do is in my Python introduction folder, I'm going to create a new file called Docker file. And in this Docker file, I'm going to run Python, and I'm going to run Python 3.9.6, which is the latest at the time of this recording. And I'm going to run the Alpine flavor on Alpine 3.13. And I'm going to call this my dev image. And what I'm also going to do is set a working directory called work, where I'm going to mount all my source code in so I can work inside of the container. So then I'm going to follow the simple steps I have in the README, which is changing directory to the Python introduction folder. And then I'm going to say Docker build. I'm going to build the dev target, which is the target I created in the Docker file. And I'm going to point to dot because that's the location of the Docker file. And I'm going to tag it as Python. So I go ahead and run this in the terminal, and that'll build up my Python Docker. And now that I have a container image built, I can go and run it by saying docker run -it. And look at this, I can mount my working directory into that work folder that I created in the Docker file. And I call my name of my image, which is Python, and I say I want an sh shell terminal. So if I copy paste this into my terminal, I am now inside of the container. I can do ls, where we can see our files that we've mounted in on the left here, and I can run Python -- version to see that we have Python installed and we have access to the Python programming language. So now that I have a terminal and access to Python, it's almost like I have Python installed on my local machine, but I don't. Now, one of the key differences between Python and other languages is that Python is a scripting language. If we take a look at languages like C# and Go, they have to compile to create assemblies that we need to run. With Python, we don't have to compile our application because it's a scripting language, meaning that Python will run the script from top to bottom. This means that any functions and variables we define will have to be defined in order, otherwise they will not be found. So there are some advantages with a scripting language. One of the disadvantages is that we need Python to be installed on the target server where we're going to run it. And it will also have to match the version. This is the advantage of Docker. If we run this application in something like Kubernetes, Python runtime is already installed inside of the Docker file. So it's running in our container. In this video, we're going to be launching a container with Python. We're going to create a folder to hold our code and add a Python file called app. This app deals with customer data. We're going to learn about functions and write a function to return customers. We're going to learn about variables to hold our data, arrays and dictionaries to hold lists of data, if statements to write business logic, loops to iterate over the data, and all the fundamentals required to build our Python app that runs in a portable Docker container. So with all of that said, let's create our first application. So in the Python introduction folder, I'm going to create a new folder called source because I'd like to keep my source code separate from anything else. And in the source folder, I'm going to create my first application called app.py because it's a Python file. Now remember that all the steps are in the README so you can follow along. So the first thing I'm going to do is in this file, I'm going to paste this snippet, which is going to be my basic application. So I go ahead and paste that. Now let's analyze that for a moment. So the first fundamental thing to learn in Python is functions. So here we can define a function with the def keyword followed by the function name. And then we have brackets. This indicates any input that this function might take. You can see the brackets are empty, so I'm not defining any input. This means this function can just be invoked without input. And then I have this colon character, which defines the end of the function declaration, the first line. Now, one of the key differences between Python and a lot of other programming languages is that Python doesn't use brackets to wrap around the contents of a function. In languages like JavaScript and C# and Go, you generally define the function name, the inputs or outputs, followed by an open bracket and a close bracket, and you have to put all the content of the function within those brackets. So in other programming languages, you would generally start a bracket and close a bracket, and then you would put the content inside of this bracket. And it doesn't matter where you place it. You can place it in the beginning like this without any indentation, or you can create two spaces. It doesn't really matter. This is other programming languages, but in Python, indentation is important. So when we take a closer look at this function, the colon character indicates where the function is starting. Then we need indentation, and everything at this indentation level is part of that function. So in my example, I use a tab, which is equal to 2 spaces as my indentation. And that means if I want to continue this function and write more code and keep it part of that function, I would have to maintain that indentation. As soon as I break the indentation, as we can see here, that is when Python knows that this function is over. So we have a function called main, and inside the main function, we're printing a statement to the terminal. So we call the print function, and the print function takes in a string, which is just a bunch of text, and we can pass anything to that function. So here I'm just passing hello world, and the print function will write hello world to the screen. Now with the function on its own, nothing will happen, so I have to invoke that function. That is why down here on line 5, I'm saying main, open close brackets. This means I'm invoking the main function. So Python will go ahead and run this function as soon as I execute this Python script. So it's very easy to run this. Because Python is a scripting language, I don't have to compile and build an assembly. So I can just say Python and the path to that script. So the script is in the source folder and it's called app.py. And if I run that, we can see it prints hello world to the screen. Now, a critical building block for building Python applications is learning how to write your own function. Functions can take input and provide output. It helps make your code modular, and it's always recommended to give a function a single purpose. A well thought out function can make code much easier to test. So instead of writing a boring function that just simply adds two numbers, we're going to start building out our application that deals with customer data. So let's start with something basic and then evolve it. So let's change this application and let's define a new function called getCustomer, which returns a customer. And then I can go ahead and invoke that function by saying getCustomer. Now notice when I run this, it's not going to print anything to the terminal. So what I can do is I can print the output of this function to the terminal like so by wrapping everything in a print statement. So I'm calling the print function and I'm passing input to the print function, and the input is going to be my function that's going to execute, and my function will return my customer, which will be printed to the screen. So if I run that, we can see now we're printing the customer to the screen. So the idea behind this is that we write a function called getCustomer, and the person invoking this function does not have to know where that customer is coming from. Currently we have it hard-coded, but it could be coming from a database or a cache or the cloud or somewhere else. So as we saw earlier, our function can return some output, but it also can take input. So functions can take input, take some predetermined action, and return outputs. So to show you an example of a function taking input, we can go to our getCustomer and we can define some input here. So let's take in a customer ID as input, and this can be any kind of ID. It could be a number, it could be a string, something that defines our customer, and then we can return that specific customer back to the client. So now our function takes in a customer ID, and look what happens when we run it. If we run it, we get an error because getCustomer is missing a required argument. That means in the getCustomer function where we're invoking it, we have to pass some kind of ID. Now I'm just going to pass in ABC as a string, and note inside of the getCustomer function we're not using that customer ID yet, and we only have one customer. So if I run this function again, we can see it's returning the value. Now you can also see that I'm not really using that customer ID, so let's go ahead and use that ID by building up some data. So what I'm going to do is create a string, and I'm going to say customer ID, and I'm going to concatenate that ID to the existing string and then concatenate the full name. So I'm just going to say name equals, and then we have our name, and here we have our customer ID. Now if I go ahead and run that, we can see it's returning customer ID, ABC, and name of the customer. Now to hold data in our application, we use what's called variables. Variables hold data in memory in our application. Holding a lot of data can take up a lot of memory, so we have to be conscious of what we store in memory. Now W3 Schools is an amazing website for learning Python. You can basically just go to w3schools.com, search for Python, and start your way from the top and work your way down. And it's important to note that data that we store in memory as variables can be of different data types. So we have text type, which is what we used so far, which is just strings. You can have numeric, which is integer, float, and complex. You can have lists, tuples, and ranges, which is for list of data. You can have dictionaries, which we'll take a look at in a second. And you can have set types, booleans, which is like true or false, and binary data. Now, so far we've been using strings. So our customer ID is a string, and our function has returned a string, as you can see here. And strings can be concatenated together. Now let's go ahead and declare some string variables. So what I'm going to do here is define a customer first name. So we're going to define a variable called first name, and I'm going to define a variable called last name. And then what you can do is you can concatenate variables to create new variables out of that. So you can see I have full name equals first name plus a space plus last name. And then what we can do is we can just say return full name, and I can go ahead and comment this out with the hash character. That means Python will not run this line of code. And if I run that code, you can see it returns our full name. Alternatively, I can return the string that I had before. I can remove this line, and instead of creating the name like this, I can concatenate my new variable. And if I run that, we can see we have customer ID like we had before and the full name. It's also important to understand that variables can be scoped to a function. So if we take a look at this example here, these two variables that we've defined here, and even the third one, is scoped to the getCustomer function. Meaning if I go outside of the function and I try to add a print statement and try to print first name, you're going to see that if I run that, I'm going to get an error saying first name is not defined. That's because first name is not accessible from outside of the function. If I take this variable and I paste it as outside the function, it becomes a global variable. And if I run the application now, we can see it will print out that first name because the first name variable is a global one and accessible from anywhere. Now, control flows are the foundations of coding. This is where we can say, if this, then do that, else do something else. Control flows are decision trees that we can add to our code to implement business logic. So you can see we're currently not using the customer ID that we're passing in. So let's write some decision trees with if statements to use the customer IDs to demonstrate how to use if statements. So as an example, we could write an if statement saying if the customer ID equals ABC or something or some value, then return that customer. Else if the customer ID equals something else or some other value, then return another customer. Else default to return empty. We just return an empty string because we cannot find that customer. So the double equal sign means we're comparing the contents of the variable to the contents on the right. So we say if customer ID is equal to ABC. That's why we're using the double equals. If we use a single equal sign, that is what we have defined over here, which simply sets the value of this string to the variable first name. So single equal signs are used to set values, where double equals is used in comparisons. So let's go ahead and copy this block into our getCustomer function, and if we run that, we can see it returns our customer because I've passed in ABC. If I change this to DEF and I run it again, we get Bob Smith, and if I change it to something else random and I run that, I get an empty customer back. So that demonstrates simple control flows. So far, we're only able to deal with single pieces of data, like variables, and our function can only return one customer. Realistically, in real-world applications, we'll want to return more than one customer. This is where arrays come in. Arrays allow us to define a list of variables of the same type. This means we can create a new function to return a list of customers. So as we can see, our getCustomer function can only return one customer at a time. So ideally, we'd like to create a new function to return all customers or a list of customers. So to do that, I'm going to define a new function up here called getCustomers. And this one takes no input. And to define an array in Python, it's very simple. All we have to do is define the variable like we declare any other variable with the equal sign, and arrays are defined with square brackets. So you can open close brackets. If you open close the bracket like this is basically an empty array. So let's create an array with two objects. And in our case, we're using strings. So you can see we have two strings, our first customer and our second customer. And then just like our previous function, we can go and return our values. So we return our array. Now to invoke that function, it's very easy. We can define a new variable called customers, and we can assign it by calling that function. So we can say getCustomers, open close brackets, and that will call our getCustomers function up here, return the result into this customers variable. And then what we can do is we can print that to the screen by calling the print function and passing our array into that print function. And notice when we run that now, it's going to print out our content of our array. Now it's very important to notice that arrays are fixed in size. So this array is going to have a size of 2, and arrays are indexed based, meaning to access any item in the array, we have to know the index number, and the index number starts at 0. So the first customer will be accessed by index 0, the second one will be index 1, and the length of this array will be 2. If we access any objects that's outside of the indexes, we'll get an error. So to demonstrate that, what I can do, I can create another variable, and I can take my array that I get back and access index 0 by using the square brackets and passing the index number. And then what I can do, I can call the print statement and pass that variable to the print statement. If we run that, we can see I've successfully accessed the first element. I can do the same with Bob, and I can return the first element and then write that inside the print statement. And if I run it, we can can see I can get Bob Smith. But watch what happens when I try access to. If I try run this, I'll get an error saying the index is out of range. I can also override an item in my array by setting the value. So I can say customers, pass in the index number, and then set the value on the right side. So you can see here we're overriding index 0 with a different string. And then to test that out, we go and retrieve that value and print it to the screen. And you can see it's taken effect here. Here's our original item in the array, and there's the updated version. You can see at the same time, if I try to update index 2 here, and I try to run this, I'm again going to get an outside of index error. So we can see our array is fixed in size. It can only hold 2 items because we defined a size of 2 items in our array at the start. So how do we append more items to the array to make it more useful? So Python arrays have an append function that you can call to add items to the array. It'll automatically expand the array. So if we take a look at our get customers function, it currently has 2 items. To add more customers, we can simply call the append function. So take a look at this. All I can do is say customers.append, and I can append all my customers to the array and then return it. So what I'm going to do is I'm going to say customers equal, I'm going to get the full list and print it to the screen. And if I run this, you can now see we have our updated array, which has our full list of customers. Now, similar to append, there's also a remove function. So I can take my array, call the remove function, and I can remove any item inside of that array. So if I run this, we can see this customer has now been removed from the array. Now, arrays provide a very powerful but simple type of list in Python. The challenges with arrays is that we have to know the index number of the item we want to access, or we'll have to write a loop to go through every item in the array. And this is not very efficient, especially if our array is very large. Now, there are a number of other types of lists in Python, but one I want to discuss in this video is called dictionaries. Dictionaries are almost like an array. However, to access the items in the dictionary, we use what's called a key. So dictionaries are key value pairs. This means we can use the customer ID as a key, and it makes it easy to find that customer if we know the ID. So dictionaries have an advantage where we can use the key to find the item in the dictionary. So in our example, we can use the customer ID to find the customer. So let's go ahead and replace our array with a dictionary. Now to do that, what I'm going to do is I'm going to remove all of this code, and I'm going to create a new variable called customers, and I'm going to say open close curly brackets, and this is the basics of a dictionary. Now what we need to do is we need to pass in our items where the key and the value is separated by colon, and every record is separated by commas. So it looks very similar to JSON format. So our first customer is going to look like this. We're going to pass in our ID. So this is our key or our customer ID, and then followed by our customer. And then we're going to add a comma so we can put the next line. So you can see I'm adding all of my customers, and they all have unique keys and all separated by commas except for the last one. And the important thing you have to know here is that you cannot reuse the same key. Keys have to be unique. This means in a real world example, we'll have to use a unique ID per customer. So now that we've converted our array to a dictionary, we can run our get customers function again and print the customers to the screen. And look at what it looks like now. This is what a dictionary looks like. So it has all our customers as defined earlier. So to create an item in the dictionary, it's not like an array that cannot be expanded, and we don't have to use the append function. What we can do is simply create or update an item by passing it the key. So in this case, I'm going to take my dictionary and I'm going to give it key H, which doesn't exist in our dictionary at the top here. And then I'm going to assign it to my new customer, and I'm going to print it to the screen. And if I run that, you can see that we have our new customer added to the dictionary. So if a key doesn't exist, it will automatically add it to the dictionary. And if it does exist, it will update it. We can also return an item from the dictionary by passing in the key. So I can say variable equals, I can pass in the dictionary with the key. And if I go ahead and run that, we can see it's returned our item. So now we have our get customers function, which gives us a dictionary of customers. But our get customer function still has some hard-coded customer strings. Let's go ahead and change that and get the specific customer from the dictionary. So this becomes really easy. All we have to do is remove all of this code we've had earlier. We can make a call to the get customer customers function to get the dictionary, and then we can return the item from the dictionary that matches that customer ID as a key. So we pass in the customer ID and return it. And to showcase both our functions, we can now have customers, which is our dictionary, call the get customers function, get the dictionary back, and to test the other function, we can say get a specific customer, pass in the customer ID and get that one back, and then print both the dictionary as well as the item. And we can see here we've got our customer and our customer dictionary. Now, loops are a very important part of programming when dealing with data structures, because a lot of the time we may not know the customer ID, or we may have to traverse every item in our array or our dictionary. So in Python, loops are designed to iterate over data structures, or if you want to run some arbitrary code in a loop fashion. Now, there are two types of primitive loops in Python: while loops and for loops. Now, while loops are a primitive type of loop where we can loop based on a condition. So take a look at this condition. I can say variable I equals 0, and then I can write a loop to say while I is smaller than 7, print the value I and increment the variable I by 1. What this will do is it'll start by defining a variable I, assigning the value 0 to that variable, and then it will evaluate this condition. I is smaller than 7, which is true. So if the condition is true, it will continue with the loop. So it'll print the value I, which we can see is 0, and then it will increment I and continue. So it will go back to the start of the statement, evaluate this condition again, and now I is equal to 1. I is still smaller than 7, so it will proceed inside the function again. It'll print I, which now is 1, and then add another 1 to I by incrementing it. So I will become 2, and then it will evaluate the while statement again and continue until I is no longer smaller than 7. So we can see here that it looped 7 times. So we can use while loops to loop simple lists like arrays. So if I expand this and I go ahead and define a new array and append all our customers, and I know there are 9 customers in this array, and then I can set my while loop to evaluate I, which is smaller than or equal to 8. And then I can go ahead and access my array by passing in I as the index number, and the index number will automatically grow as we loop through the array and increment the number. And if I go ahead and run that, we can see that we've looped through our array using a while loop. Now you can see the side effect of this is that we have to adjust our while loop because we have to know the size of our array. So I can dynamically do this by calculating the size of the array using the len function. So instead of putting a value of 8 here, I can say I is smaller than or equal to len, the function of len, and pass in my customer array to the len function. This will return the length of the array, which is 9. And then I can subtract 1 from that number. So this will mean that I is smaller than or equal to the length of my customer array minus 1. And if I go ahead and run this, we can see that we've looped our array. Now, while loops are very powerful because we can write that condition. For loops are better designed to iterate over data such as dictionaries. So let's go ahead and remove our array that we have here. We can call our getCustomers function to return our dictionary of customers, and let's go and loop through them by writing a for loop. So to write a for loop, we start with the keyword for, and then we can define a variable, which is going to be a variable of each of the items in our dictionary. Now, because a dictionary is made up of keys, we have to say for customer ID, because that is our key in our dictionary. So we'll say for customer ID in customers. So then we pass the colon character to end the for statement, and then we follow the same practice as function definition. So everything inside the indentation becomes part of the loop. And in this loop, what I'm going to do is I'm just going to run a print statement. I'm going to print every customer by passing the dictionary, opening and closing the square brackets, and passing the customer ID. And if we run that, we can see we've traversed our dictionary. Now, so far so good, our application is starting to take shape. But one important thing to note is that in the real world data is not made up of just simply strings. For example, a customer is not just a simple string. Customers have first name, last name, date of birth, a customer address, and other fields. This is where classes come in. Classes allow us to group some variables together and form an object. So in our case, our customer will be a customer object, and it'll have multiple fields that we can access. So to convert our customer from a string to a class, we have to go and define a class. So let's go to the top of our script and define a new class called customer by using the keyword class. And the same pattern as defining functions and loops, we have to put a colon and put all the content of the class inside of the indentation. And what I'm going to do is I'm going to define some simple fields for our customer. Customer ID, first name, and last name, which are all going to be empty strings by default. Now to use my class, I can make an object out of it. So I create my object by specifying a name equals and then the type, which is a class. And then I can proceed by accessing the fields on that object by calling each of the fields and assigning them a value. And then what I can do is I can say print and print my object to the screen. And when we run this, we can see that it's printed our customer object, but not really in a readable format. Now it's important to notice that classes can contain all sorts of data types as objects. So you can create strings, integers, date times, or even functions. So for example, I can have a function where I can calculate the customer's full name. So we can define a function saying def, and let's call this function full name. And for this function, I'm going to have to pass in self, which is the actual object itself that the class represents, and then a colon character. So then I'm going to have an indentation, and then I'm going to return my content. And what I want to return as part of this function is I'm going to say self.firstname, which is the first name field defined up here for the customer that we're accessing. And then I'm going to concatenate a space followed by self.lastname. So I'm computing the full name inside of a function definition. And then to use that function, I'm going to call the print statement of my object, and I'm going to say .fullName. And if we run this, we can see it prints out the object's full name. Now you can see it can be quite tedious and a lot of lines of code to fill out each of the values of our customer on a separate line. So this is where constructors come in. Constructors allow us to build up a class and defining values at the time where we instantiate that object. This means that instead of defining my object like this and then defining each field on a separate line, I could create something where I can just pass the fields that I want to instantiate into the class like so. And then that means I don't have to write each of these lines. So I can use a constructor to set the values on the class automatically. So let's take a look at how to define a constructor. So in Python, we use the following syntax. We say def, we pass in two underscores, init __. This is a keyword in Python to build up a constructor. Then what we're going to do is we're going to open close brackets. We pass in self, which is the object we're working on, followed by key value pairs. So in this example, I'm just going to say C, which is going to stand for customer ID, and I'm going to equal that to blank. And then I'm going to say F to set the first name, and I'm going to make that blank as well. And I'm going to make L, which is the last name, and I'm going to make that blank as well. This allows us to set default values for the fields coming in. And then instead of making them blank, I'm going to assign customer ID to C, first name to F, and last name to L. This will set all of the values coming in on the constructor to my fields on the object. So this means I can go ahead and instantiate my object like so. I can say my object equals new customer, pass in the values customer ID, first name, and last name in the order as applied above. And before we run it, we actually have to make sure we set the fields on the object itself by saying self.customerID, self.firstname, and self.lastname. And when we run that, we can see we're printing out our full name of our object. So now instead of using a dictionary with a bunch of strings representing our customers, let's convert our application to use a dictionary of customer objects, which will represent more realistic type of data. So if you take a look at our getCustomers function, you can see we define a dictionary and every item as a key as well as the value. The value are just a bunch of strings. And as you see down down here, we've defined a customer object like this. Now, instead of creating a string, what I'm going to do is replace my string with the actual object like that. And what I'll want to do is replace all of these objects to look the same. So now we still have our key in our dictionary, but we also have our customer object defined like this. And then we return our customers. So now we can proceed to return our customers by saying customers equals get customers. And then let's loop through each of them and print their fields. So what I'm going to do is write a for loop saying for customer ID in customers. And then I'm going to write a print statement. And what do I want to print? I want to print the customer, and I want to access the customer value by passing in the key to access each of the customers inside of our dictionary. And then I can run the full name function like so. And when I go ahead and run that, we can see we've now printed each one of our customers, but this time using the actual object. So now that we've learnt about all the fundamental basic components of the Python programming language, let's put our application all together inside of a Docker container. This will make our application lightweight and portable so we can pass it around to other people so they can run it as well. Now if we take a look at our Docker file, we're starting from Python 3.9 in a very light Alpine Linux container, and we call this our dev environment, and this is our working directory. And so far we use this Docker file to mount our source code so we can work inside of the container. And this means we can take advantage of Docker multi-stage. So what we can do is we can write another stage, which is also from Python, the exact same image we run before, but we can give it a different name like debugging. And then we can actually go and add a debugger and use this stage for debugging tools. So this will help us to create an image for development purpose as well as debugging purpose, and keep the debugger outside of the final image. If you want to learn how to debug code using VSCode and Python, check out my video down below. But for this video purpose, we're going to skip the debugging step and we're going to create our final stage, which is going to be from dev. So from the stage at the top here, and we're going to call this our runtime. Now, because the dev stage doesn't have the source code as part of the image because we mount it in during our working, we're going to copy the source code into the image, into an app folder, and then we're going to create an entry point which tells Docker how to run our container. It's going to start up our container by saying Python and the location of the script. So to run this now, I can go ahead and exit out of my container, make sure I'm in the Python introduction folder, and I can say docker build dot, because that's where my Docker file is, -t, and then the tag of my image. So I'm going to go ahead and run that, and that'll build up a Docker container that we can run. And to run the application, it's very simple. I just say docker run and the name of my application. And when we run that, we can see our Python script has executed inside of a Docker container. So hopefully this video helped you understand the very core fundamentals of the Python programming language and how to put it all together inside of a Docker container. Be sure to check out the link down below to the application source code, because in the next video we'll take our learning to the next level by writing an HTTP web server and exposing our data as a microservice. And if you liked the video, be sure to like and subscribe and hit the bell. And check out the link down below to the community page. And if you want to support the channel even further, be sure to check the Patreon link in the description down below. And as always, thanks for watching, and until next time, peace.